I will be starting soon, by the way. Testing 1 2 3. Testing 1 2 3. Okay. Seems like it's working. Okay. So we're going to be starting soon. Okay. Okay, so here we go. The book is called Chance by Amir Axel. A guide to gambling, love, the stock market, and just about everything else. We're going to go ahead and skip the introduction. Chapter 1. What is probability? Probability is humanity's attempt to understand the uncertainty of the universe, to define the indefinable. A probability is a quantitative measure of the likelihood of a given event. If we are sure that an event will occur, we assign it to a 100% probability. If we are sure that an event will not occur, we assign it a probability of 0%. Other events, those neither certain to occur nor certain not to occur, are assigned probabilities between 0 and 100%, or equivalently between 0.00 and 1.00, which is the strict mathematical scale of probability. If an event has a probability of 0.5, that is 50%, then it is as likely not to happen. An event with a probability of 0.1 or 10% is not likely to take place, and an event with a probability of 0.9, 90%, will likely take place. Of course, these same numbers can be written as fractions, so that 0.1 becomes 1 out of 10, 0.5 becomes 1 out of 2, and so on. And by the way, I will be skipping over graphics because there's no real way for me to actually show you the graphics. Now, the assignment of a probability, a number between 0 and 100%, must be done in accordance with certain laws of logic and mathematics, derived by Pascal and Fermat, and others, so that it is valid. We want the probability we assign to an event to be correct. which is to say that in the long run, if we make many trials of the event, say rolling a die and noting the outcome, the probability will agree with the results. For example, we assign the number 1 out of 6 to the probability that a die will show a 5. And in fact, in the long run, 1/6 of the rolls of a fair die will show a 5. When early humans rolled that bone die before history began, they noticed that about 1/6 of the time a 5 came up, or they would have if they weren't too busy running from woolly mammoths. The same held true for the other numbers. But we derive the probability by other means, not by rolling the die a million times. We've come a long way. You will find an understanding of probability theory is extremely useful. You already use the basic form every day. Should you pay for a cab or chance the subway? Pull off the highway and get gas now, or wait for a cheaper price? But a deeper understanding will help you make better decisions in business, love, and any other areas of life. The probability expert I.G. Good claims that probability theory predates the human race. He argues that animals have a sense of probability. A predator might instinctively assess the probabilities that the prey will choose among various escape routes, and chase down the route that is more probable. The purpose of this book is to teach you something about the theory of probability, to help you define the indefinable, so that the world around you makes sense and you're able to make better decisions in your life. Chapter 2. Measuring the probability. I want to tell you a secret. Measuring probabilities is as simple as counting. Simply count the possibilities of an event and divide this number by the total number of possibilities. Of course, all the possibilities we count must have an equal likelihood. If one possibly is more likely than others, it must be weighed appropriately, but we'll deal with this later. For example, in a roll of a fair die, there are 6 equally likely outcomes: 1, 2, 3, 4, 5, and 6. How do we know? Well, it's intuitive, and perhaps the early humans who played with the bone die had the same intuition. The die is perfectly symmetric, or at least ideally it is. It has 6 sides, so each of them is equally likely to come up. Whenever we have a situation with equal likelihood outcomes, the probability of any outcome is the ratio of the total number of outcomes corresponding to the event to the total number of outcomes. For example, what is the probability of rolling an even number? There are 3 even numbers, 2, 4, and 6. Out of 6 equally likely numbers, 1, 2, 3, 4, 5, 6. So the answer is 3 of 6, or 1 out of 2, or 50%. Even odds, as they say in Vegas. Let's look at cards now. If I have a deck of 52 cards that is well shuffled, what is the probability of drawing an ace? The assumption that the deck is well shuffled gives us the equal likelihood of outcome for any one card out of the 52 cards in the deck. Since we have 4 aces, the aces of hearts, diamonds, clubs, and spades, out of 52 cards equally likely to be chosen, the probability of an ace is 4 out of 52, or 1 out of 13, or about 8%. This is demonstrated in the figure below. Chapter 3. The Law of Unions. When we want the probability of the occurrence of one or two events, when we want the probability of the occurrence of one of two events, we have a law for finding it called the union law. The union law says the following: the probability that at least one of two events will occur is the sum of the probabilities of the two set. Sorry, one more time. The probability that at least one of two events will occur is the sum of the probabilities of the two events minus the probability that both events will occur. You might find this language tricky at first, but a quick example shows just how simple it is. What is the probability that the card we draw out of a well-shuffled deck is either a heart or an ace, or both? The answer by the rule above is probability of a heart plus probability of an ace minus probability of the ace of hearts. The reason for this is that the ace of hearts is both a heart and an ace, so we need to subtract the possibility. So we need to subtract that possibility. Otherwise, we will count it twice and overestimate the probability of drawing a heart or an ace. Chapter 4. Independence of events. The above has mostly been simple and intuitive. We now come to more realistic situations. Here we encounter one of the most important assumptions in probability theory, the assumption that random processes are, in many situations, memoryless. If a die turns up 2, does that increase the chances that the next roll will also end up in a 2? If the die is fair, rather than loaded, the answer is no. In this case, we say the process of rolling the die is memoryless.